Dr. Fakro and Dr. Azlisha. We are from Group 3 are going to demonstrate on our IoT based project named IoT Smart Home System today. I am SANJIVAN KARUNKARAN going to explain on reasons why we are choosing this project in the first case. We are choosing this project because we found this project is very useful to our mankind today, especially to elderly people aging after 60 years and above. Smart home automation gives senior people the comfort they need to live longer in their homes with a reasonable level of independence. The functioning of the home may be monitored and managed and integrated communication systems given inhabitants choice for available service. This IoT grants enable connection between people and things with anybody at any time, anywhere, and ideally utilizing any networks of service. A smart home's various installed device and system can communicate with one another by sending information and commands. In addition, automation uses electricity and water in a cost-effective and efficient manner, minimizing waste to large extent. By preventing circumstances where lighting and air conditioning are left on for longer than necessary, it has capacity to conserve energy. A smart home system can help you save money and the environment.
Block diagram of our project. So the main goal of this project is to design and to develop a solution for the challenges that the need specified exist for older individuals. The goal of system design is to determine which modules should be present in the system and their specifications and how those modules interact with one another to generate a result. So as we can see in this figure, it shows the block diagram for the smart home system for aging household that has been designed by us. So the main component for the system is the microcontroller, or we called it as Node MCU. So this is basically the main brain of this whole project. So this Node MCU will be connected with Alexa app, Synric Pro, or the manual switch. And once we give commands through our voice, the Node MCU will send the message to the relay, and the relay will turn on the lights, and the lights will be given a power source from AC. The microcontroller also controls the whole system of the machine, and this microcontroller Node MCU was programmed to read input signals from 4 different types of inputs and act accordingly. So this picture depicts the flowchart of smart home system. Basically, when we turn on the light using any of the 4 inputs, the light will basically on and off according to the signal received. The challenging part is all the signal will correspond with each other, where we can switch on manual button, the status in Alexa app, and Synric Pro server will display accordingly. For the voice recognition part, the device will on any smart devices when the user says Alexa. But before this, the smartphone must be installed the Alexa app. Beforehand, to integrate IoT, Synric Pro used as an interface to register devices and get updates from anywhere and everywhere we are. The credentials that given in Synric Pro is used in the coding, which then will be uploaded into Node MCU. As for the working part, the Node MCU must be connected to internet, which the internet's SSID and password must place inside the coding for Node MCU. After that, we can use Synric Pro in the web to control it from anywhere. We can open Alexa app in our smart devices, then also control the output via buttons and voice commands. We can also control the outputs with manual switches in case our smart devices runs out of battery. The manual switch will work if the Wi-Fi is connected and when it's not. Hi, I'm Shashi from Group 3. So this is the design structure for our project, which is smart home system for aging household. The structure design is divided into 4 parts, which is the manual switch, 4-channel relay, Node MCU, and also the output lights. So let's look at the hardware components for this project. At first, this is the Node MCU ESP8266. So this project uses Node MCU as a microcontroller, since IoT applications and object linking are growing. And Node MCU is an open source platform based on the ESP8266 chip with a 10 Silicon Extensor 32-bit LX106 RISC microprocessor. And it can connect sensors to Internet of Things devices and transport data over Wi-Fi. Next up is the generic 5V 10A 4-channel relay. So this relay offers two main benefits. First of all, isolation of low voltage system from high voltage systems allows low voltage devices like Arduinos and AC light bulbs to handle large power demands. And secondly, this relay breakout is rare, and 4 channels of 5 volt activation relays regulate 250 voltage AC at 10 ampere. Next up is the tactical switch. So by manually pressing the operating part, a tactical switch permits current to flow in an electrical circuit. An input signal is supplied through the switch to activate a piece of machinery or equipment. Next up is the AC power source. So as we all know, we have AC and also DC power source. So AC power can fluctuate power and frequency, and an AC power source powers or tests a device under test by replicating electrical grid failures, harmonics, surges, or other phenomena that potentially damages it. Next up is the bulb. So this bulb is one of the crucial part in this whole project, because this project will be tested whether it's working or not by using the lighting up of this bulb or not. So this bulb is actually converts electrical energy to light. When electric current flows from this AC power source, the bulb produces light. A switch stops and allows the electricity to flow through the circuits. That's why we connected it with the tactical switch. As for software development, we use three main softwares for this project, which is Arduino IDE, Alexa, and also Centric Pro. So Arduino IDE is this open source program that has worked with almost all Arduino modules, including the sensors. This Arduino IDE was used to write and compile code for the Arduino module as indicated. So official Arduino software makes code compilation easy enough for a beginner. Next up is the Amazon Alexa. Amazon Alexa is actually a virtual assistant, and it plays music, creates to-do lists, sets alarms, streams podcasts, and plays audiobooks. Alexa manages smart devices as a home automation system, which is perfectly fine for our project. Finally, the Synric Pro. Synric Pro enables developers to integrate IoT development boards such as the Raspberry Pi with third-party applications, or with Amazon Alexa and Google Home with a reliable skill. The API can be used to retrieve device logs, find devices, update devices, and get account details.
Alexa, turn on main gate. Alexa, turn off main gate. Turn all lights. Alexa, turn off hall light. All on. All off.
In conclusion, this project focuses on older people with disabilities and is an intelligent assistive home automation system for aging households. One benefit of this project from a safety standpoint is that because it uses IoT and voice commands from Google Assistant, it also can help older people to move less. Through this, they can simply use their voice to command the fan, light, and gate to turn on and off. Furthermore, we can control it from anywhere using Synric Pro on the web. In light of the fact that only the elderly can operate the system, we can guarantee their safety at home. When it comes to environment, IoT technology used particularly in smart homes can result in a net decrease in global energy consumption and environmental impact. Technology for home automation can cut down on carbon emission and energy use according to a research. In general, we understand that no project will ever be perfect. It undoubtedly has flaws that must be addressed and improved. This project is still relevant and the concept can be commercialized. There are several suggestions for future improvement to this project, such as installing other home appliances such as ceiling fans, air conditioning, switches, outer gate system, and so on.